we are going to discuss the speed control of your DC machine, shunt machine. You know the meaning of shunt. You have a shunt winding. You have a rotating winding, which is called armature. They are in parallel. If you want to control the speed of a DC machine, which is shunt in nature, there are two possibilities. You can put a resistor, variable rheostat here, then you connect the power. Or you can put a variable rheostat for your field winding electromagnets. Two possibilities. You have two freedoms. You can change the flow of current in your armature winding, or you can change the flow of current in your field winding. So that's what is shown here. You can have a look. How to control the speed? Speed is equal to 60 ES. You know the meaning of ES. ES is applied voltage divided by number of conductor into flux. So this is the formula for calculating your speed. So 60 ES divided by Z into 5. How to do it in practical? Two ways. You can put a series of resistor here and connect in series with your armature by adjusting this contact. I showed you in online, right? You move this. For example, if you keep it here, minimum resistance. If you keep it here, maximum resistance. Okay. By adjusting the resistance, you can control the current through this one. If you keep this one here, maximum current will not flow because you have huge resistor. It resists the flow of current. If you keep this one here, you send maximum current to your armature. It's clear to you? Similarly, here you put a rheostat. Same, you apply the current. For example, this contact, if is here, you directly feed the full current. If you keep this contact here, you travel all the resistance and you feed your electromagnets. That is called field winding. So you can control by a variable resistor the current flowing through your field winding or armature winding. Now let us see the characteristics, what happened. So for that, we are going to have a real-time results, which is shown here. I'm going to plot in the x-axis the speed as well as the armature current, and in the y-axis torque. So this is the one graph. You can find the characteristic of your DC shunt machine motor, the speed torque characteristics and the current characteristics. So you can able to see what happened your torque with respect to current, with respect to speed. First, let us see the speed characteristics. So this is my speed axis, all represented in per unit. What is the meaning? This is 0 speed, 100% speed, 200% speed, 1500. So 1500 here. This is 3000. It's clear to you? We are representing everything in per unit. And this is the y-axis, which is maximum torque, 100% torque. Say 40 Newton meter. This is 40 Newton meter. This is 80 Newton meter. It's clear to you? Now let us see the characteristic of the speed torque characteristics, which is given here. This is the speed torque characteristics. So at 0 speed, you can see the torque is more than 200%. More than 200%. So I want to give you a small input here. We call it as a kickback effect. What is kickback effect? If there is any electrical machines which is in stationary condition, this happen also in transformers. We are going to discuss with Neil Pop. So when you apply, what is the voltage available here? For example, I'm giving you 220 volt, full capacity. It has a full power. My machine is in standstill. Okay. If I apply full power to this table, what happened? It will run again, right? Similarly, when you apply a full power to your electrical machines, it has to tolerate them, right? At the beginning, what happens if you apply a full power, it will return the same applied power little back to the supply. This is called kickback effect. So kickback effect is nothing but when you apply a rated power to your electrical machines, it in the beginning, a transient period, a short time, it generates very high current. So you know the relationship. If high current, high torque. That's why you get a torque which is greater than 100%, near to 200% for a short period of time. Then, as you increase your speed near to the rated value 1500 RPM, then you can see the torque is almost near to zero. It's not true. because you have a rotating part armature. It has its own weight, am I right? It has its own weight. So any electrical machine, by virtue of its characteristic, is at its own weight because you are rotating a big, huge conductor coil. You are rotating in the air, so it has its own weight. So usually the no load current will be like 10 to 15%. It is not zero. It means you are going to have 10 to 15% load by itself. Then remaining you are going to load externally. It's clear to you? So that's why in the beginning, your current rise very high due to kickback effect. This is not explaining your textbook, okay? So what is kickback effect? Kickback effect, any stationary machines, it can be a transformer, it can be a motor, it can be a generator. When you're applying a full power, a short period of time, it returns the power maximum to the load so that the current increases. Because the current increases, your torque is directly proportional to the current. You get a very high value for short period of time. Then as the speed increases, reaches the rated value, your torque is almost not really zero. This is ideal characteristics. It can be around 1 Newton meter or 2 Newton meter if the rated Newton meter is 40. For example, I have a machine for 40 Newton meter, maybe 1 Newton meter, 2 Newton meter, created because of its own rotating part. Because of the weight. See the machine, its weight, am I right? The rotating part has its own weight. So this is the speed torque characteristics. So speed torque characteristic at the beginning of your shunt machine, the torque rise more than 200% because your current rise to 200%. So this is the characteristic of torque speed. Then I'm going to look at the characteristics between current and torque. Look at the characteristics. Why the torque goes high? You see, steeply increases. They are linearly proportional. That's why in the beginning, the machine takes large current, will produce large torque. After a few fraction of a second, it comes to normal position. It's clear to you? So in any machine at stationary position, it will take a huge current and produce a torque at the beginning, and fraction of seconds, it will come with stable values. It's clear to you? Any question about torque speed characteristics? In one graph, both the characteristics is given. So this is your current. Zero current, zero torque. As the current increases, the torque also proportionally increases to the maximum. So here, the maximum current is 100%. At 200%, you have 200% torque. See the relationship. So this is 200%. 200%, you have 200% torque. 100% current, you have 100% torque. So torque and current are directly proportional. Speed and torque are inversely proportional. Straight. You are running at 1500 RPM. You put more people, more load, speed comes down. Any question about the torque speed characteristics? Then about series motor. You know the meaning of series motor? So the series motor, the simplest way I can represent, this is my field winding. This is my armature winding, which I represent as like something like this. Okay, this is my brush. This is my armature. So I put motor. This is FF. This is electromagnet. This is my series motor. This is a very complex motor. It's a very complex motor. Since you are not conducting real experiment in the laboratory, you didn't understand the impact of it, because this is a motor where you should not start at no load. If you start this motor at no load, your armature, the rotating part, will fly away. I will explain you the characteristics. So, for example, you can see your field winding is in series with the rotating part. So, field electromagnets, field winding is in series with your armature. So, please note your series motor should never be started with no load. At least 30 to 35% should be loaded. So, what is the meaning? If I'm having 40 Newton meter load, 40, so torque we have to decide. So torque is a load. So if you are going to have an electrical machine for 40 Newton meter, or I say current is 10 ampere, I should start at least with 4 or 5 amperes. This is the basic requirement of a series machine. If you are not loading the machine without a load, armature will fly away. Let us see the characteristics. The load current of a series motor to off normal value is 0.5 into flux, which is equal to 2 times of your speed. As I said, the most important is the load current. Here, if you look at the circuit, the current which is taken by your field winding is the same the current taken by the armature winding. Both the current is the same. It's not a different. In shunt motor is different. I1, I2, IF and IA. Here, the current is the same. That's the big challenge. Both has the same current. It's clear to you? Both has the same current. So that the load of the current drops to 1.50% of your normal value. So what happened? The flux is 50%, which is equal to 2 times of your speed rise. So speed rise 2 times with respect to the flux. For example, if you reduce the flux by 50%, the speed increases by 100%. Twice. It's clear to you? So for this reason, always your series motor is not recommended to start without load. At least 50% you should be loaded. It's clear to you? Any doubt? I can explain you with another way. Look at here. If you look at my slide, torque is proportional to armature current into flux. See my formulas, the textbook. This case, what happened? T is proportional to armature current. Again, what happened? The flux. Look at here, flux. The current produced by this flux is I. So what happened? This is also become I. So IA square. It takes 2 times the current. The torque is proportional to IA square. You understand what I am saying? So that's the reason. If you are not loading with 50% load, your armature get a speed which is 100%, twice the rated speed, and the armature will fly off. It's clear to you? Because torque is inversely proportional to speed. Torque and speed are inversely proportional. You see the relationship. T is proportional to IA square. IA square. And if this is IA square, what happened? They are inversely. So that's why in the beginning, 50% load is required. Let us see the characteristics. Again, the same way. I'm going to take on the x-axis speed as well as armature current. So this is 0%, 100%, 200%, and 300%. On the y-axis, we have torque 100%, 200%, 300%. First, let us see the characteristic of the torque speed. So look at the torque speed. At zero speed, you go to 300 times. Look at the characteristic of shunt motor. Then you will understand why I am saying 50% it should be loaded. Look at the peak. You are just above 200%. Whereas in series motor, you are going above 300%. What happened? The machine will disintegrate. It's clear to you? So you should not start at no load condition. This is the reason. So as the speed increases, you can have a look. Near to 300 times the speed. Look at here, 300 times the speed. Your torque comes very near to the zero. So the starting speed of your series motor is very, very, very high. You need to put a lot of load to bring down the speed. So wherever you want high speed application, for example, I can give you an example. Traction systems. So what is traction? Train. Train at the start, they take high speed, right? Whatever be the load, 100% load, 200% load, the train starts at the same speed, right? Irrespective of the load, they can run at high speed, right? So that application, you have to choose series motor. So if you are designing a machine where you have more load at the start and you need a high speed, you have to go for series motor. If you want a constant speed, constant torque, you have to go for shunt. Clearly, constant speed, constant torque, you choose shunt motor. High speed, high torque, choose series motor. You can look at here, still 300% speed you are going, torque is not zero. Similarly, I'm going to look at the current characteristics. At the beginning, you can see the current relationship steeply increases. As the current increases, the torque goes to 300%. You see, only in 1.5%. Look at the characteristic of your shunt machine. You are getting more than 200%, if the current is 200%. Whereas in series motor, your current is very limited to 100, I say 150%. You reach 300%. That's why high speed, high torque application, you have to use series motor. The most important thing at the beginning of your series motor, you should start with 50% load, always loaded with 50%. For example, if you are not keeping 50% load, what happens? Your flux goes down very much and the speed increases like 300 times and the armature will fly off. In order to protect your series machine, you have to start your series machine at least with 50% load. It's okay. Any doubt about the characteristics? So you have to look the previous characteristic and compare with this one. Then I am going to see compound motor. These equivalent circuit may confuse you. At the final slide, I given a very simple way. You can easily understand what is a compound motor. So compound motor, what is the difference? So you have two windings. Sorry. You have two windings for your motor. This is your field winding. This is your armature winding. I'm right. You include some additional winding here for connecting with the field. Then it is called compound motor. I will show the easiest way in the next slide. You can have a look. I have the field winding, my field winding, and this is my armature winding. Look at the armature winding. It's coming here. I'm right. Then I include some shunt field. Look at here, additional winding. So this is called the compound motor. You can have a look on the compound motor equivalent circuit. This is the compound motor equivalent circuit, and this is the characteristic. So in compound motor, we have two types, either series or shunt. We have two types: long shunt, short shunt. If you look at my first presentation, I showed you the classification. So for a DC machine, long shunt and short shunt. Just hold on a second, something. Hello. Hello. So long shunt and short shunt, what is the meaning? How you connect your rotating armature winding in short to the field winding or long to the field winding. Based on this classification, we have two types. One is differentially compound and cumulatively compound. What is the meaning? In differentially compound, the flux will come down. In cumulatively compound, you increase the flux. So you have the different characteristics. Here on the x-axis, we have torque. Y-axis, we have the speed. Torque varies from 0 to 1.6%, and the speed varies from 0 to say 1.6%. It's like 160%. Let us see different motor. For example, this is a characteristic for a differential compound motor. You can have a look at 0 torque. You have 80% speed. As the torque increases, you can have a look. The speed increases, and around 100% torque, you get 100% speed. So this machine is particularly a different machine. You can have a look. If the torque increases, speed should come down. But this machine, the torque increases, speed also increases. It's a special machine. If you look at the shunt motor, at 0 torque, you have the maximum speed, say around 1.5%. As the torque increases, the load increases, the speed comes down. You see, this is the characteristic of a shunt generator. So differential compound, torque increases, speed also increases. Shunt motor, torque increases, speed comes down. Then about compound motor, you can have a look at 0 speed. You get, 0 torque, you get 1.4 times the speed. So 140%. As the load increases, the torque increases, the speed also decreases and comes down to near to say 50% when you have a torque of 150%. Look at the characteristics. So this is very important. Then about the series motor. At the series motor, even at 0 torque, you get speed 1.6. That's why we are not interested. You understand? So we need to load the machine at least with 50%. So you can have a look at 40% load. You have a speed of 1.6. As the torque increases, Look at the characteristic of your series motor. It comes down and reaches, say, around 90% of your speed when you have a load of 1.6. For example, if you are not going to have any load in your series motor, you get 1.6% speed, the armature will fly off. That's why we start at least with 50% load or 40% load to bring down the speed from maximum to minimum. So you can have a look at maximum load. You can go up to 60% more than the rated values for a series motor. So this is the characteristic. But all the motors, if you look at unique characteristics around their rated value, they will have the rated speed. So this is my rated load. Look at the characteristic. This is a 100% load. At 100% load, I have 100% speed. All the machines. Now, what is the purpose of these characteristics? So I want to design a machine where at 0 speed, I want start like 80%. Then I go for differential machine. For example, I want a machine with characteristics where the load increases, speed also increases. I go for differential component. I want a machine with a high speed and high torque. I go for series machine. In an application where I want at the start high speed, and as the load increases, speed should come down, then I go for compound motor because at 0 load, I have 140% speed. As the load increases, I come down. So it depends on your application requirement. You can choose shunt motor, series motor, compound motor, or differential motor. What is a shunt motor? You can have a look. As the torque varies, the speed only drops from 1.1%. This is 1.1% or 110%. So it's like 110%. The maximum it drops only to say little less than 110%. So the speed is almost constant, mostly constant. You can have a look. Even if you increase the load to 1.6, that's why your shunt motor is a constant speed, constant torque motor. Whereas your series motor is high torque, high speed motor. It's clear to you? And compound motor is high start speed with gradually reducing speed. Whereas your differential compound motor, your load increases, speed also increases. So based on your application need, for example, you want to design a machine where I'm going to increase the load, my speed also increases. I go for this. I want a high starting torque, high starting speed. I go for series motor. I want a constant power application, constant speed application. Example is mill, cotton mill. In cotton mill, you can find n number of motors, all are doing the threading. If one machine runs low speed, what happens? Threading fails, you will not get a good cotton cloth material. Impossible. Then you need a unique speed of all the machine. I go for shunt because constant speed. Any doubt about the characteristics? Can I go to the next one? Now, how to reverse the speed of your DC machine? I am running in clockwise direction. I want to change it to anti-clockwise direction. How to do that? DC is very easy because you have plus and minus. Change the polarity. For example, if the machine is running in clockwise, when I connect positive to positive, negative to negative, I want to change into opposite direction, anti-clockwise direction. Connect negative to the positive, positive to the negative. So you can have a look. This is a shunt field motor, shunt winding, series winding. You have the machine, and you have the original compound motor. You can have a look. If I want to reverse the direction, see the polarity changed. I connect negative to positive, positive to negative. It's applicable for all the 3 types of motors. I mean, compound motor, shunt motor, or series motor. Just change the polarity. It's clear to you? Finally, this is my final slide. You may be thinking, what is a series motor? What is a shunt motor? What is a compound motor? I'll give you a clear idea. This is separately excited. So this is my rotating part, which is called the armature. This is my electromagnet. I apply separate DC here. I apply separate DC here. Then it is separately excited. What is a shunt motor? So you have a shunt motor here. This is my rotating part, which is an armature. In parallel with my field winding electromagnets. This is called shunt motor. What is a series motor? The rotating part is in series with the electromagnet, which is the field winding, and series motor. What is a compound motor? How it is connected? That's most important. You can have a look. This is my rotating part, the armature. This is my field winding. If I consider only these two, is a shunt motor. But I put an additional winding here, S1 and S2. This is called short connection because you see the connection is very short. I connect directly to the field winding, very short. The distance, how I'm connecting between the armature winding and the field winding, how close, that is for short shunt. This is long shunt. You can have a look. This is the armature rotating part. I go here, come here, then I connect to the field winding. So please have the view on this one. This is not available in your textbook. Easy to understand what is a long shunt and short shunt. I mean, how you are connecting your field winding. Shortest part, it's called short shunt. Longest part, long shunt. In this, we have two types, cumulative and differential. Cumulative and differential. For example, what happened here? If the flux produced by this winding and this winding add, we call it as cumulative. The flux produced by this one and this one subtracts, we call it as differential. Same application. That's it. Okay. You understand what is the meaning of a short connection and long shunt? The flux produced here. Flux produced here because these are field winding. Okay. If these two flux, phi 1 plus phi 2, add phi 1 plus phi 2, we call it as cumulative. Differential, phi 1 minus phi 2. That is the classification. I written here. If you add both the flux, cumulative. If the flux are subtracted, you get differential. Same applicable for long shunt. Whatever the flux you produce here, phi 1, phi 2, if it is added, cumulative. Phi 1 minus phi 2, differential. Clear? This is a complete classification of your DC machine in one slide. So somebody asked you, how do you decide compound motor? How the armature winding is connected very close or long with your field winding. It's connected very close, short. This is connected in a long way, long shunt. Clear? Done. What happened to the flux produced by these two guys? If it is added, cumulative. If these two subtracts, then differential. Same applicability. This is enough for you. Don't go too much inside. So these all I given here. You can have a look. Flux are added, cumulative. Flux are subtracted, differential. Finally, I like to conclude the DC motor. The speed control in a DC motor is comparable with induction motor. Next, we are going to discuss induction motor after completing DC machine, where I will say, you can see the characteristic of it. Induction motor, almost the speed characteristics are most similar. So the final conclusion, the DC motor runs at greater speed when compared to induction machine. DC motor has different classification, shunt, series, compound, and separately excited. Then about series motor, always used for high speed, high starting torque with the load. What is the meaning of high starting torque? At the beginning, I want 80% load. I start with 80% load. I have to go for series motor, not shunt. Then about shunt motor always used for constant torque and constant medium speed application. Finally, we already seen what is the Wall-Leonard method. It's a cascaded operation because we need three machines. One is AC machine, which controls the generator for the armature to rotate, and the armature is connected to another motor. Then we control the motor speed. It can be power from the grid to the load or load to the grid also possible. So this is a cascaded operation and it's very good for sensitive speed control and braking. Any question about the introduction? Now I finished very important topics. Say my slide is only 15. So please have a print on my slides so that it can be useful for your preparation for the exam. So we can have a break for 15 minutes. And finally, we solve only one problem. Today we can wind off.